ended the lesson yesterday dividing out like terms. So we are going to apply that to GCF today. Okay, so we're going to apply that idea. So this is the very first type of factoring that we are going to do. We call it greatest common factor, or GCF. So the very first step when you're factoring of any kind is to always take out your greatest common factor. Okay, or known as GCF. So that's your first step. No matter what type of factoring you're going to use, is to take out a GCF. What is a GCF? Okay, it's the largest number and variable that each term of a polynomial has in common. Okay, and I'm going to show you what I mean by that. So it's the largest number and variable that polynomials have in common. So for example, numbers 4 and 8. What's the biggest number that 4 and 8 have in common that you can divide out? 4. Okay, 4. What about 60 and 18? You may need a calculator today for this. Okay, what about 60 and 18? What's the biggest number that you can evenly divide 60 and 18? You think 6? So if we do, I don't think there's anything bigger than that, right? 18 divided by 6 would be 3.
3.9.
Well, 9 goes into 18, but does 9 go equally into 60? It doesn't, so it definitely would be 6. Good, 6. Okay, now let's add in the variable idea. Okay, so now we have 2x squared and 10x. Think about the number. What number would you pull out of both of those? 2. Okay, now we know that we're going to pull out an x. Okay, when it comes to taking out variables, you want to go with the exponent that is least. So there's 2 x's here and 1 x here, so you can only take 1 out of both, because that's what they have in common. Does that make sense? Okay, now, if this was 10x squared, what could I pull out? I could pull out an x squared. Does that make sense? So this is just the first step in factoring. It's problem solving. Problem solving will use the whole thing. Okay. So if you take out a variable, okay, you want to take out the lowest exponent on that variable. So at number 4, let's start with the number. What number can you evenly divide 25 and 55? 25. So take that out. Okay, now we have an x to the 4th and an x to the 3rd. What can I pull out? X to the 3rd. Okay, so you pull out the lowest exponent. Okay, so when you factor out a GCF from a polynomial, you'll divide. So we're going to combine what we did yesterday with what we just did on the previous questions. Okay, I want you to figure out what number goes evenly into 27 and 18 and is the biggest one. 9. Okay, so we know that 9 is a GCF. Is part of your GCF, I should say. What about our y? We're going to pull out y to the what? Y to the first power. So we have a y squared and a y to the first. We can only take out a y to the first. You tracking on that? You okay? Okay. So now, actually, okay, so what we do now is we divide 9y out of both terms, and this is what we learned yesterday. So when we divide out that 9y, okay, I have 27 divided by 9, which is 3. And then I have y squared over y to the first. What do I do with my exponents there? Subtract them. So 2 minus 1, I would have just y left here. Okay, now we'll do positive 18 divided by 9, which is positive 2. Okay, and then what do I have left for my y's? Nothing. They cancel. Good. You just did your first GCF problem. Okay, so you decide what's the GCF, and then you divide it out. if we wanted to check our work, okay, so this is what we have. Let's go backwards. Let's distribute our 9y. 9y times 3y. What does that give me? 27y squared. And then 9y times 2 is 18y. Does that match my original problem? Yes. Okay, so that checks out. We know that we did it correctly. Okay, questions, issues, concerns? All right, let's keep rolling with it. We'll keep practicing. If you're a steps person, here's your steps. Okay, if you like steps, here you are. That's what we just did. All right, so factor each expression. What is our GCF here? What number would you pull out of 8x squared and 12x? You would pull out 4. Okay, and then what about for your x's? X to the first. Okay, so that means we're going to divide each term by 4x. Okay, so for that first term, what would I have remaining? 2x. 8 divided by 4 is 2. X squared over x to the first. We subtract the x. All right, now what do I have left for my second? Just 3. Your x's cancel out, and the 12 divided by 4, we get 3. Right now, you want to check it. Redistribute. So 4x times 2x would give me 8x squared. 4x times 3 would give me 12x, and that's what we started with. So we know we're good to go. And if you want to go to the bathroom, you can. All right, number 6. What would be your GCF? Okay, give me the whole thing, not just the number. Give me the whole thing. 5m squared. 5 goes into 5 and 35 evenly. It's the biggest one. Okay, and then we have the lowest exponent we have is the 2. Just how we know that we pull out a 5m squared. All right, you're going to divide both terms. I'm going to let you do that. Go ahead and divide both terms by yourself. See if you can get it. All right, we should have n minus 7 left. Do you agree with n minus 7? Yeah? Okay, good. We'll go ahead and check. So that would give us 5m cubed minus 35m squared. And that is what we started with. Okay, so we have a few left. I know there's lots of practice here. Number 7. Yeah.
If it's easier for us to put the one in front of the variable, if it's just
Okay, 11x minus 2. What's your GCF? What's your GCF here? 1. You can pull 1 out. Is that really useful?
No.
No. So in this case, we would say we don't really have a GCF. So we would say that this is not factorable. Basically, what we're saying there is this is in its most reduced form. There's nothing else that we can do there. Okay, so that one's not factorable. Okay, number 8, GCF. What do you think your GCF is here? 2x. Good, 2x. You're going to pull a 2x out of each term, which just means you're dividing it out of each term. So go ahead and do that. I'll let you finish that one up. It's looking like we would have 3x plus 5 left on that. 3x plus 5. You in agreement? Okay. Number 9, what do you think is our GCF here? 3. 3 goes into 3, and it goes into negative 24. So we would have left x minus 8. X minus 8. So sometimes the GCF will be just a number, and sometimes it'll be a number and variable. Or sometimes it could be just a variable too. It could be any combination of those. All right, number 10, what's our GCF? 5x. 5 goes into both 10 and 15. It's the biggest one that you can divide by, and then they both have an x in them. So you would have 2x minus 3 left on that. Are you tracking with me? Good, okay? Any questions? Not only if I asked you to classify it. Yeah, I wouldn't worry about that right now. All right, number 11. So now we're going to get a little bit bigger here. We're going to expand a little bit. So now we have 3 terms in number 11. Takes a little bit more to kind of figure it out. What would be our GCF in number 11? 4. Because 4 can be divided out of 4, 8, and 24. Would we pull out an x? Why not? Yes, 24 does not have an x with it, so we can't pull an x out. So here we're only going to divide out 4. You divide out of all 3 terms on this one. So here you would have x squared plus 2x plus 6 remaining. Any questions on that? For number 11? Okay, number 12, what number would we pull out? 2. And we would pull out an x, right? So if you look at your exponents, we have 3, 2, and 1. Like I said, we pull out the lowest exponent. So we would just pull out an x to the first. Less. So we would divide each term by 2x. What's my first term going to be? 3x squared. Good. And then we have minus 4x. What's at the end? Plus 1, right? You have to be really careful there. A lot of times people will just not write anything. But if you think about it, something divided by itself is always 1. So we always have a 1 at the end if we've divided everything out. Okay, number 13. What number would you pull out here? Huh? 1, right? There's not a number that evenly divides 10 and 3. So there's not a number we can pull out. What about a variable? Can we pull out a variable? No, because they're different, right? One has an x, one has a y. We can't factor this at all. So we would say that this is not factorable. Not factorable. Okay. Now, another word to use for this, and we'll use this a little bit more in our other factoring methods, is if you cannot factor something, we call it prime. Prime. P-R-I-M-E. Prime will be a word that we use more frequently throughout our factoring units. So, for factoring lessons. So if it's not factorable, we call it prime. Okay, I think the next parts are, oh no, we have 14, 15, 16. Oh yeah, we have 3 more. Okay. 14, what would you pull out? 10? Any variables? No. Watch your signs on this one. You want to make sure that you keep your signs. So you have x squared minus 4x minus 5 left on that one. Be very careful of those signs. All right, what's our GCF at number 15? 2. Which figure? X squared. X squared. 2x squared. So we would be left with 4x squared minus 1 on that one. Again, be really careful of that minus 1. You want to make sure you write that in. Just because everything divides out doesn't mean you leave it blank there. All right, and number 16. 8, right? 8 goes into all three numbers. What about our variable? X to the, what do we pull out? X to the what?
Just X.
X to the first, because it's the least exponent that we have. So we have a 3, a 2, and a 1. You can only pull out the lowest there. All right, so we have x squared plus 3x minus 4. So all you're doing there is simplifying. And you can totally use a calculator on these if those numbers get too big and you want to make sure that you're doing it right. Okay, there's practice right below. So go ahead and work on those. You can check your answers at the bottom in the solution box.